In a high school auditorium, a simple question sparks a powerful debate. Is the Earth flat or spherical? Two students stand on opposite sides, each ready to defend their perspective. But this is more than an argument. It is a journey through evidence, observation, and centuries of scientific discovery. For some, the flat Earth idea begins with a simple observation. The horizon looks flat. Water appears level. Online communities question space agencies and challenge accepted science. They argue that asking bold questions is not ignorance, but independence. Others look upward for answers. Through telescopes, they observe shifting constellations. They notice that different hemispheres see different skies. Astronomy reveals patterns that suggest a rotating, spherical planet. The stars quietly tell a story older than civilization itself. Standing at the ocean, the horizon seems perfectly straight. To the human eye, there is no obvious curve. Flat Earth supporters argue that if Earth were curved, we should clearly see it. But is what we see always the full picture? As ships sail away, something interesting happens. They do not simply shrink into the distance. Instead, they disappear bottom first. This effect matches the mathematics of curvature, a subtle bend too gradual to notice at ground level, yet measurable over distance. During a lunar eclipse, Earth casts its shadow on the moon. That shadow is always circular, no matter the angle. Only a sphere consistently produces a circular shadow from every direction. For over 2,000 years, this observation has supported a spherical Earth. In 240 BCE, a Greek scholar named Eratosthenes conducted a simple experiment. By measuring shadows in two cities at the same time, he calculated Earth's circumference with surprising accuracy. No satellites, no modern technology, just geometry, sunlight, and careful observation. Airplanes often follow curved routes on flat maps. To some, this looks suspicious. But on a globe, these routes are straight lines, called Great Circle Paths. Navigation systems, used worldwide, rely on spherical geometry to function correctly. From high altitudes, the curvature of Earth becomes visible. Astronauts, satellites, and even high-altitude balloons capture this perspective. Independent organizations across many countries confirm these observations. The view from space reveals a blue sphere suspended in darkness. Modern students repeat ancient experiments. Measuring shadows in different cities, they calculate the same curvature discovered thousands of years ago. Science does not depend on belief. It depends on results that can be repeated by anyone. The flat Earth model describes a disc-shaped world, with Antarctica forming an outer ice wall and a dome covering the sky. It is a concept that attempts to explain visible phenomena from a different perspective. But how well does it match measurable reality? Some arguments focus on distrust of institutions. Could space agencies manipulate images? Skepticism can be healthy, but extraordinary claims require extraordinary evidence, especially when thousands of independent scientists collaborate globally. Objects fall at the same acceleration everywhere on Earth. This consistent downward force is measured as gravity. It explains falling objects, orbiting satellites, and even the motion of planets. Density alone cannot account for these precise, predictable patterns. As Earth rotates, sunlight reaches different regions at different times. This creates time zones. Day and night move across the planet in a continuous cycle. The spherical model naturally explains this global rhythm. Weather systems rotate differently in each hemisphere. Hurricanes spin counterclockwise in the north and clockwise in the south. This phenomenon, known as the Coriolis effect, results from a rotating spherical Earth. Images of Earth from space are not isolated to one nation. They come from multiple countries and private companies. Live streams from orbit, satellite communications, and global positioning systems all rely on a spherical Earth model. When evidence is examined together, astronomy, physics, navigation, geometry, a consistent pattern emerges. The spherical Earth model explains far more observations with fewer contradictions. Standing again by the ocean, the horizon still looks flat. But now we understand something deeper. Human perception has limits. Science extends those limits through measurement and mathematics. Debate is not about winning. It is about learning. Questioning ideas is essential, but so is following evidence wherever it leads. True critical thinking requires both courage and humility. The shape of the Earth is more than a scientific fact. It is a reminder of humanity's ability to explore, calculate, and discover. Across centuries, across cultures, we continue to test, observe, and learn. And as our planet turns quietly in space, the pursuit of knowledge continues.